Welcome to JSR Maths Academy. Now, in this video, we are going to discuss about real numbers of class 9, synopsis regarding to the exercise 1.1, and this is a part 2, that means second part of the synopsis of exercise 1.1. And in the previous video, in the first part of this video, we discussed that every terminating decimal is a rational number, and non-terminating repeating decimal is also a rational number, and we learned that how to representing the rational numbers on the number line, representation of rational numbers on the number line, and decimal form of the rational numbers we learned. Okay, now in this video we are going to discuss about these two important concepts, that is of representing the non-terminating repeating decimal, representing the non-terminating repeating decimal in the form of P by Q, non-terminating repeating decimal in the form of P by Q, and the next synopsis that we are going to discuss about inserting the rational numbers between the two given rational numbers, between the two given rational numbers. So these both are synopsis that we are going to discuss in this video. So let us discuss about the first point, that is of representing the non-terminating repeating decimal in the form of P by Q. Before that, let us discuss that how to represent a terminating decimal in the form of P by Q. Let us discuss that how to represent a terminating decimal in the form of P by Q. Okay, let me take an example. 0.24 is that. So, is it a terminating decimal or non-terminating decimal? Yes, you are correct. It is having a finite number of decimal places, so it is a terminating decimal. So to convert this terminating decimal in the P by Q form, we need to write a given decimal number without considering the decimal point. We have to write the given decimal number without considering the decimal point. Then afterwards, as we have decimal point, we need to take 1 in the decimal in the denominator. As we have two decimal places, we need to write 2 zeros after the 1. After the 1, we need to take 2 zeros in the denominator. So you will get it as an 24 by 100. It can be further simplified as 2 50s, 2 12s. Again, it will be divisible 6 25. So this can be written as 6 by 25. So this you learnt in the primary sections. In the primary classes, you learnt that how to convert a terminating decimal in the form of P by Q. Okay. So now in this video, we are going to discuss about how to convert a non-terminating repeating decimal. How to convert a non-terminating repeating decimal in the form of P by Q. Let me take an example, that is express 1.62 bar in the form of P by Q. Express 1.62 bar in the form of P by Q. That means we need to write this in the form of fractions. So let us write let us take let x is equal to 1.62 bar, and this bar indicates that repetition of these two digits infinitely many times. That means x can be written as 1.626262. Likewise, these two digits being repeated infinitely many times. And now you need to understand the two important terminology, that is of period and periodicity. Okay, or with help of these two terms we can solve this problem, or else you can write this decimal number in the form of P by Q very easily. Period in the sense, in the given decimal number, what digits are being repeating. In the given decimal number 1.62, this 6 and 2 are repeating. So This 62 is called as a period. The group of digits which are being repeating is called as a period of the given decimal number. The group of the digits which are repeating is called as a period of this given number. If you take a 1.62 bar for only 2, in this case what is period? Only 2. Okay. And if you take 1.6235 bar for 35, then what is the period? 35. Okay. I hope you understand about the period. And periodicity means what? In this period, how many digits are repeating? 2 digits are repeating. 2 digits are there. In the period, how many digits are there? 2 digits. So, periodicity is 2. Periodicity is 2. Okay. Now, here before that, let me suppose this is the first equation. As periodicity is 2, then equation 1 should be multiplied by 10 to the power of 2, that is of 100 on the both sides. If periodicity is 3, then equation 1 should be multiplied by 10 to the power of 3, that is of 1000 on both sides. If periodicity is 1, then that should be multiplied by 10 to the power of 1 by, that is of 10. As here periodicity is 2, we need to multiply this equation 1 by 10 square, that is of 100 on the both sides. That means multiply equation 2 by 100 on both sides. So that here what we will get, we know x is equal to equation 1, we know that x is equal to 1.6262 and so on. And for this I need to multiply it by 100 on the both sides. On multiplying any decimal number by 100, that decimal point moves towards the right as the multiplier contains the number of decimal, as the multiplier contains the number of zeros. As multiplier containing two zeros, then this decimal point moves towards the two places towards the right. So this I can write as 100x is equal to, on transporting this decimal point to other side, that means towards the right for the two steps. This I can write it as 162.6262 and so on. And this is of 100x. I am supposing this as a second equation. And first equation, if you observe the first and second equations, and subtracting equation 2 and equation 1, that means I am subtracting equation 1 from the equation 2. Equation 2 is 100x is equal to 162.6262 so on, and equation 1 is 1.6262 so on. Okay, now on subtracting it, 100x minus x, that is of 99x, is equal to 162 minus 1, that is 161. Point here 6 minus 6, 0, 0, 0, 0. So that means you get it as 19x is equal to 161. 99x is equal to 161. From this we can write down x is equal to 161 by 99. X is equal to 161 by 99. So this is a P by Q form, or else a rational form of 1.61 bar. 1.61 bar is equal to 1.62 bar is equal to 161 by 99. 161 by 99. This is how to convert this non-terminating repeating decimal in the form of P by Q. And by observing this form method, no need not to worry about this method. Okay, sometimes you can solve this problem very easily with help of the shortcut. And I will try to cover that shortcut and easier manner wherever it is necessary when we are discussing about the exercise problems. Okay, no need not to worry about this length of this answer. Okay, so I hope you understand regarding this how to convert this non-terminating repeating decimal in the form of P by Q. Now let us discuss about terminating decimals, or else let us discuss about inserting the rational numbers between the two given rational numbers. Inserting the rational numbers between the two given rational numbers. So let me take an example. Okay, as an example, I am taking our textbook question, exercise 1, 4th question. I am taking exercise 1, 4th question as an example and I am explaining here. Insert three rational numbers. Insert three rational numbers between 3 by 5 and 2 by 3. Insert three rational numbers between 3 by 5 and 2 by 3. Here, this problem, that means in the maths, one problem can be solved in many methods. Okay, so I am explaining in the one of that methods. Okay, so if you did not understand what I am going to explain, you can ask me to explain another method. Okay, so I will try to answer to you in the WhatsApp. Okay, so firstly you need to understand that how many rational numbers are to be inserted. Means three rational numbers. That means we need to write three rational numbers between 3 by 5 and 2 by 3. We need to insert three rational numbers between the 3 by 5 and 2 by 3. So how we are going to insert or how we are going to write that three rational numbers between these two numbers means in this method, firstly we need to make them as a like fractions. Make them as a like fractions or like rationals. Why we need to make them as a like rational? Actually, like fractions means what? The fractions with the same denominator. If you take 1 by 17 and 19 by 17 is there. These two fractions are having same denominator as a 17. So these two fractions are said to be what? Like fractions. In the same manner, given rational numbers has to be make them as an like fractions. That means we need to make the denominators as equal. To make the denominators as equal, we need to take a LCM of 5 and 3. LCM of 5 and 3 is 15. That means we need to make each fraction with the denominator as a 15. That means first fraction you need to make as a denominator as a 15. So we need to multiply it by 3 by 3. And second fraction also should be make the denominator as a 15. So to make this 3 as a 15, I need to multiply it by 5. So numerator also should be multiplied by 5, so that you get a 9 by 15 and 10 by 15. Now we wrote or else we write that given rational numbers with the same denominator. After writing them in the same denominator, just to observe the numerator parts. On observing the numerator parts, numerator of first fraction is 9, second fraction is 10. Do we have any other natural numbers between 9 and 10? No. There is no natural number which lies between 9 and 10. In that case, you need to observe the question. In the question, how many rationals to be inserted? In the question, they ask us to insert 3 rational numbers. Then what is the successor of 3 rational numbers? Sorry, what is the successor of 3? That is 4. So, to insert 3 rational numbers between these two, 9 by 15 and 10 by 15, you need to multiply each fraction by 4 by 4. That means 9 by 15 should be multiplied by 4 by 4, and 10 by 15 is also should be multiplied by 4 by 4. Then 9 fours 36 by 15 fours are 60, and 40, 10 fours are 40 by 15 fours are 60. Now observe this. Now observe the numerator parts of these numbers. What are the numerators that we got here? 36 and 40. And what are the natural numbers which lies between 36 and 40? That are 37, 38, 39. So write 36 by 60 and 40 by 60, and write that natural numbers which lies between 36 and 40, that are 37, 38, 39, and simply to take a denominator 60, so that these three numbers will lies between the given rational numbers. What are the three rational numbers that we obtain? 37 by 60, 38 by 60, and 39 by 60, or 60, sorry. So these three are the required rational numbers which lies between the given rational numbers as a 3 by 5 and 2 by 3. Okay, this is how to insert the rational numbers between the two given rational numbers. And there is another method which is also called as a mean method. I will try to explain that method with another example in the next video. Okay, thank you.